All right, well, welcome back. This is our final series of presentations for the day, and in this series we have 4 speakers. The first 3 will be covering topics of network design, picking up from the previous 2 speakers, and the 4th then will be addressing consequences of not following proper operational procedures. So our next presenter for the network design is Eric Stevenson from the Bay Area Air Quality Management District. Eric is a chemical engineer with over 20 years of experience in the environmental field. He's designed remediation systems, performed air pollution emissions permitting, testing, and monitoring. He's currently the Director of Technical Services for the Bay Area Air Quality Management District, and he manages the air monitoring, laboratory, quality assurance, and data management programs. He's a member of various committees and work groups, including the National Association of Clean Air Agencies, or NACA, Monitoring Steering Committee. Eric's presentation today is entitled Monitoring Requirements and You. Eric Stevenson? Oh, there he is.
Good afternoon. I had a couple requirements before I agreed to do this. I asked that I be put in a room with a bunch of guys who are used to being out in the field, that it be very hot, that we have a heavy lunch, and that I follow really smart, interesting speakers. So they've matched all of that for me, so you guys are in for a treat. I'll be pointing out people that I see snoring throughout the presentation. So I also wanted to take a quick review of what we've learned so far. Let's see, what we've learned so far is if you're in a canoe with Darcy and Gwen, you're going to have a good time. Dogs aren't free, and you don't need to stockpile sriracha sauce. Evidently, in the South Coast, they're going to let that still be made, so thank God for that. Okay, I'll get serious now. So I'm going to talk about network requirements. Earlier this morning, we talked about PQAOs, which, by the way, would be a great drinking game. You just don't want to get PQAO as the word that you've got to drink on. So network requirements. When we talked this morning about following SOPs and things like that, what we're really talking about is managing the number of variables so that you can compare that data across a wide range of things, right? Well, one of the other variables is what that network looks like. So now we're going to talk about how EPA and the state put together a whole bunch of requirements on the networks so that we can compare data not only from an SOP sort of way, but also on a network design sort of way. So how many of you guys have gotten a call from the office and they say, hey, could you go measure how far it is to the nearest tree? And you're wondering, what the hell are these guys smoking back at the office, right? Well, one of the reasons they do that is to make sure that you're meeting all the network requirements. So that's what we're going to talk about now. This is my favorite picture of a monitoring station. Our job is a circus, isn't it? Isn't that awesome? Okay. So when we talk about network requirements, usually we're talking about federal network requirements because those are the ones that have regulations that talk specifically about where you can monitor and how you can monitor. So what are the objectives of the federal network design? And basically, you've got 3. You want to provide air pollution information to the general public. You want to determine compliance with the NACs. And you want to support research studies, epidemiological studies, trends analysis, things like that. Part of that involves other objectives and requirements. And what you're trying to do is find locations that are representative of particular scales. So what does that particular monitoring site represent as far as space goes? You want to make sure that you, in most cases, pick a site that's representative of certain populations, right? So you want to be in areas that have large populations for the most part. You want to have data that represents actual concentrations. So you don't want to be locating your station right at the outlet of, say, a dry cleaner, right? Because that's not going to represent much besides what that dry cleaner is putting out. And we've talked about a lot of documentation, but you want to document that you've met all these uniform requirements and that you have the appropriate data quality. So just backing up kind of what everybody else has said about documenting everything that you do. So part of the network documentation is the annual network plan. So we'll be talking about that with two folks later on, both from the EPA perspective and then, of course, from the FUN district perspective. So we've got a number of different monitoring design site types. You guys probably wonder, why am I monitoring at this particular site? Why am I monitoring over here? What does this do? There's requirements to that, and the guys in the office are trying to make you guys monitor at those particular locations and meet these requirements. So one of the most important one is the highest concentration site. Karen talked about that a little bit, as did Jason, that those are kind of the canary in the coal mine sites. Another site that we look at is typical sites that represent populations of concern. So usually you've got, a site located in LA, San Francisco, that represent large populations. You can also have source impact sites, so sites near particular facilities. And EPA is starting to move much more in that direction. It used to be that we kind of located our ozone sites and things like that out away from industry, away from roadways. Now we're starting to move in closer. We're starting to locate near industry and near roadways. Then we've got our background sites. Not too many of us have those. We've got a Point Reyes site on the coast in Northern California. I'm not sure what you've got in Southern California, but there aren't too many background sites around here. We've got transport sites so that, one district can blame their problem on the next one downwind. You've also got sites that Jason was talking about that deal with visibility and welfare impacts, your CASNet types of sites that are designed to represent degradation of the environment. And then last on the list is state and local needs. Okay, so how do we determine how many sites we've got to have? This slide is fun. So I want you guys all to determine the CBSA in your neighborhood by looking at the map here. So that's how a lot of the population-oriented sites are determined, by CBSAs, or core-based statistical areas. Gets confusing because in some of the regs it's MSAs, it's CBSAs, it's CSAs. It all kind of talks about the same thing if you look at this map, because it's broken up into all of those different things. So depending on what the regulation calls for as far as the population metric that they're using, it all fits into this map. So take a look. It's beautiful. There'll be a test later on. Where do you live? What is your CBSA? It's established by the Office of Management and Budget. So you can't just look at the EPA regs. That'd be too simple. We've got to go look at other sources of information to get that. And basically, CBSAs are used for ozone, PM10, PM2.5, and near roadway location. There's other methods of locating these stations. There's NCORE, which was developed by EPA, and they kind of determined where they wanted those sites and went out, and everybody kind of worked together to determine that. There's SO2, which is based on population and emissions inventory. That's kind of a new one. Haven't had to do that one before. There's source-oriented. We're starting to move more towards this. This is lead and near roadway. Do we have anybody from San Diego? Great, let's talk all about them then. They were the lucky folks who, along with the Bay Area, had to monitor at general aviation airports for lead. It's a fun time had by all. That's a whole other training session, so I'll move on. There's research sites, and then, of course, there's QA/QC sites, co-located sites, things like that help determine if the methods that are being used are applicable across the network. Okay, Next thing to get really excited about, scales of representativeness. Before I was married, this used to get me all sorts of dates. Hey, let's talk about scales of representativeness. So there's a number of those scales. Microscale, it's source-oriented. Okay, middle scale starts to move back a little bit farther. Neighborhood scale, further back. I'll give you some graphical representations of that because when I started looking at everybody else's presentations, I noticed they had all pictures. I didn't have any, so I thought, hey, this is where I can put a picture in. So here's microscale, basically used to determine impacts from sources, plants usually, and it's used to really measure what's coming off of that plant. Okay, doesn't provide a lot of other information about anything else other than impacts from that plant, right? Okay, middle scale, again, kind of what's happening to a population nearby, but it's supposed to be a little bit more representative of what a population near a source might be experiencing. Neighborhood scale, that's the most common one that we're used to because you've got to weigh the impacts of, say, traffic and things like that with population. And so that's designed to be representative of a larger area. Then there's huge scales of representativeness. You've got urban scale, which is 4 to 50 kilometers. And they're usually representative of large swaths of land, gnats, toxics, things like that that are placed within areas to be far away from impacts so that they're representative of larger areas. You've got regional scales of representativeness, 10 to 100 kilometers, usually transport sites, PAMs, things like that, so that you've got even larger areas. Those are usually stations that have a lot of effort associated with them. PAMs, a lot of effort. You want it to represent a large area if you can. And then you've got national and global sites. Those are more like national park sites, CastNet sites, things like that where they're pretty pristine so that you get an idea of what global background is. Okay, now we get into the meat and potatoes. This is where everybody gets excited when I start to show graphs and lots of words. So basically what we do is we associate those scales of representativeness with station types. So this particular slide provides an idea of this. Now, usually when you get to this part of the regulation and you're reading through it at night when you can't sleep, you'll notice that a lot of this stuff doesn't say shall, it says should. So you're trying your best to get these scales of representativeness associated with these types of stations. And EPA leaves you a little bit of wiggle room there so that you can design your network with a little bit of flexibility, not a huge amount of flexibility, but a little bit. So your high concentration sites are usually micro, middle, or neighborhood scale. And when we talk about high concentration micro scale, those are usually like SO2, something that's associated with the plant, which falls into the next one, which is source impact, again, micro, middle, and neighborhood, because you're trying to get an idea of what those impacts are from that particular source that's impacting those areas. Population is usually neighborhood or urban scale. And then general background, you can be at neighborhood scale, but usually it's regional or global. Okay, so now federal required air monitoring. What is the purpose? You've got to make sure that you meet the minimum monitoring requirements. Now, most people think in California, we've got a monitoring site every 20 feet for the most part compared to the rest of the nation, right? So this should be pretty easy. It's surprising. It can be difficult for us to meet some of the minimum monitoring requirements. It could be part of a federally required program, something like NCORE, CSN, NATS. Another required site is one in which you get maximum concentration or provides information about a boundary. And Jason had talked about that, where you're trying to figure out, is this the end of my non-attainment area and the beginning of an attainment area, or the other way around? Another type of site monitors transport. So you're trying to figure out, how much of the next region or the next air basin's concentrations are caused by upwind sources. Or it supports exceptional events. So you've got, all your national park monitoring stations. So when Yosemite burns, you have an idea of what those exceptional events boundaries are. You also have monitoring that's required as part of your SIP or your maintenance plan. And then again, last on the list, meet state or local needs. Okay, I put this slide in just to give you an idea of how many monitoring stations California actually has compared to other regions. So that's what the bar chart is on the right-hand side of the screen. Region 9 is the highest bar. And that's basically caused by California and all the monitoring that we have. Okay, now we're getting into specifics about particular compounds. Just to give you an idea of why the guys back at the office trying to locate these stations are driving you crazy with their requirements. No, you can't put it there. It has to be 3 blocks over here. Can't you find me something over there? This is why. Because it's based, for this is near roadway requirements. So if you fall into a population, it tells you how many stations you have to have and when they have to be operating. So if you're a CBSA, go back to the map, figure out which CBSA you are in. How many stations do you have to have? When do they have to be operating? It's all part of the regulation. If you're in that next band of population, there's the number of stations you have to have and when they have to be operating and so on and so forth. The real fun part of the monitoring requirements comes in the text afterwards, because that's where it gets complicated. It would be easy just to go out there and go, 2.5 million, I got 2 stations, I'll just plop one here, I'll plop one there, done. No, there's other stuff on top of that. So for example, for near roadway, you have to find a location that considers AADT. Anybody know what that is? That's right. Rhubarb, that is right. Annual average daily traffic counts. So it looks at how much traffic is going by on a roadway, and then you take into consideration traffic mix. So if it's got more trucks, it scores higher on this sliding scale. If you've got less trucks, it scores lower. Has to be damn close to the roadway, right? 50 meters. How many of you guys have a near roadway site in your network? Okay, well, I'll move on then. The reason this becomes important is because once this starts and we start to get information about it, because the epidemiological information indicates that populations near roadways have worse health outcomes than people further away from roadways, it's likely that, what they'll find out is the folks that are near the 2.5 million stations, the people in the dense cities, they're getting impacted like crazy, and then they're going to say, okay, let's move out to the rural places and find out, if it still holds true. So if it's happening to South Coast and the Bay Area and stuff like that, it's going to eventually happen to you guys too. So you get to look forward to that. Give me a call when that happens. Glad to help you out. Caltrans, great partner to work with. One of the other things that we start to see is that once you put this network in place, because initially this near roadway network was designed for NO2, right? NO2, great. Hey, we'll just put it out. We'll just put NO2 in there. No big deal. Don't worry. And then the next reg comes out. Oh, put CO out there. Don't worry. Just put CO. Oh, and then you might as well put PM5 too. Oh, and then, so once you've got that station kind of built, might as well just load it up with everything you got. So that's kind of the way it works. In addition to that, usually when you get a requirement like this, there's other requirements put behind it. And one of those is for CBSAs with greater than 1 million, you've also got to have a neighborhood or larger scale NO2 site that helps give you an idea of, well, okay, it's this bad near the roadway. What is it like a little bit further away? Okay, the forgotten criteria pollutant, poor PM10. Let's all feel bad for PM10. So I just put this in here because, PM10 gets no respect, except, of course, in San Joaquin Valley. Great Basin, yeah, sorry. A lot of respect in Great Basin. This just gives you an idea of how the older regulations were kind of set. It was based on population and then expected concentration. And that was kind of the way it worked. So if you were kind of expected to have high concentrations, we're just going to put a lot of stuff out there and, kind of had that sliding scale drop away as time moved on. One of the things to remember about PM10, you got to associate a scale with it. So it's usually middle neighborhood, just like just about everything else. There's a slide coming up with a chart in the next one that helps you with that too. So little exciting stuff. It isn't a cup of coffee that gives you a bullet, but it's foreshadowing. It's not quite as good as. Never mind. So PM25, more of a new requirement. So it gets a little bit more complicated. It's based on population, right? But there's other things that you've got to take into account. And again, you kind of get the sliding scale. Because as Jason pointed out, we're also kind of in this time of reduced resources. So we're trying to be much more effective of how we put these monitoring networks out, right? So what you'll see here is that around the NACs, you have more instruments. When you're away from the NACs, high or low, doesn't matter, you get to reduce the number until you start, so if you're high, you come down, you got to put more in, and then as you get low, you get to take them off again. I'm doing pretty good not hitting the microphone with my hand. I talk with my hands a lot, and I'm really concentrating, so taking you guys into account so you don't get those loud bashes. And then we have a whole bunch of text here about PM25, and okay, it isn't just the numbers up here. There's a whole bunch of other requirements. And some of the things in there can be pretty subtle. So think about it for a second. What they're asking you here is they're saying PM25 must be cited to be representative area-wide. So typically, again, it doesn't say shall, it says typically. Neighborhood, urban scale, those smaller scales may be okay. So, you can cite it, as long as you're meeting that requirement. One of the other things that's interesting here is it says at least one must be located in an area of expected maximum concentration. Okay, so anybody got an idea what that means? Exactly. So that means that you're supposed to be trying to put instrumentation in those areas of maximum concentration. But we all know that those areas can change day to day, time period to time period. So it becomes very difficult. And these are the kinds of things that you've got to rationalize in your annual network plan. I put this here. It's representative of this particular PM25. It's my expected highest concentration. You're actually calling those kinds of things out in your annual network plan. So you've got to rationalize how that particular monitoring piece of equipment represents this requirement. So it can be tricky. And then, of course, near road, so everything's tied up nicely. Ooh, sorry. More respect for PM10. Ozone. You'd think ozone would be pretty straightforward. We've been doing it forever, right? Pretty simple, pretty easy. Maybe not. So we've got the normal sort of population. We've got this sliding scale around the NACs, so a lot like PM25. And then, again, we've got at least one monitor must be located to record maximum concentration. So what if you've got two maximum concentration sites in your area? Say, on a particular day, this area has maximum concentration. On a particular day, this area has maximum concentration. Is it based on your design value? Is it based on something else? How do we do that? And how do we rationalize that in our annual network plan? And then the thing at the bottom where it says sources of NOx should be considered. What's a big source of NOx? Cars, right? So if you're near a roadway now, you've got to take into consideration NOx. Well, in urban areas, It's tough to get away from roadways, but you've got to be in areas that represent populations. So you're trying to weigh all sorts of different things, and then you've got to go back into your annual network plan and explain how you're meeting all of these things. So when the guys in the office are calling you and asking you all these seemingly weird questions and doing it year after year after year, this is what they're trying to compile: is how am I meeting all these requirements that are trying to get at a particular thing, trying to be reasonable and science-based with enough flexibility so that you can get the data that makes some sense, but at the same time, you've got to be able to rationalize that. So it's all a very difficult process when you're talking about meeting those network requirements. That's why your bosses are crazy. Okay, so here's your distance from roadways. I'm from the Bay Area, so, pretty dense urban area, not quite as dense as LA. But I'll tell you what, trying to meet the minimum distance from the roadways nowadays with those kinds of AADTs, pretty difficult in an urban area. So what we found is that those stations that we've had for ever and ever, all of a sudden there's development along a street, and now you're climbing above this AADT, and you're no longer meeting minimum distance. So what do? Well, you're no longer meeting the requirement, so that ozone station may not count. And if it doesn't count, are you still meeting the number of ozone instruments within your CBSA now? So there's a lot of things that you're trying to take into account. One of the things that's great about being involved with science is that you can actually use logic to, argue your case. So what we'll do is we'll go through a whole bunch of analysis and say, yeah, we're kind of not making the minimum distance, but science says that the NOx aren't affecting our readings. Easier said than done. I can say that here, but that's 30 pages of graphs and charts and data that we have to send to EPA and then put that in our network plan and get the comments from the public. What does this mean? So, you guys still there? Yeah. Okay, thank you. Just want to make sure. It's a tough afternoon, I know. Okay, so SO2. This is kind of a new treatment of our old friend SO2. Didn't used to matter too much. Most of us in California didn't care too much about SO2, right? No really big sources for us. No coal-fired power plants, all gone, right? Well, this kind of brings us back into SO2 world. It's population-based, and it's emissions inventory-based. Okay, so kind of a new sort of way of setting up monitoring stations. In addition to that, if you're lucky enough to be required to monitor for SO2 near a source, again, you've got this requirement that says you've got to be in the area of maximum concentration. Okay, so you've got to use modeling to determine that, or you've got to use monitoring to determine that. And you've got to be able to show that that's the area of maximum concentration. And they're not kidding around on this one. They really want maximum concentration. So you're going to have to use modeling and a whole... Damn. Almost got through the whole thing. Woke one dude in the backup, though. That was great. So, you've basically got to prove that if you take the monitoring choice, you've got to show that's going to measure maximum concentration. And you've got to be able to document that in your annual network plan. Why is that important? We keep talking about it. And, of course, we're going to have Dr. Kerpius and Joel come up afterwards and talk about their network plans. But the reason that's important is, as Debbie talked about today, community groups are using those annual network plans to ensure that we're doing the monitoring that the regulations require. So you've got advocates on both sides now pushing. It used to just be kind of industry or folks who are really in the know. Now it's everybody. So everybody's talking about it and pushing in different ways. So those monitoring network plans are becoming really, really important. And we've got to make sure that we are documenting everything, network design, all of our uses of QAPs and QMPs and everything with a Q, to ensure that people know we're doing what we're supposed to be doing. By the way, the SO2 regulation isn't finalized yet. They're they're still kind of going through iterations of how they're going to do it. So I'm not sure how many of you guys have SO2 sources in your districts, but if you do, it's a lot of fun. You'll have a good time. When we go to the brewery tonight, ask me about it, and I'll be happy to tell you what I think. Lead monitoring, we kind of talked about this. Sounds like San Diego isn't here, so we don't get to cry on each other's shoulders about this. Lead used to be, for the most part in California, we stopped doing lead for the most part a long time ago. But now it's coming back. They lowered the standard by a factor of 10. Boom, all of a sudden, all those TSP instruments that we all used to run, we're having to run them again. Nice pieces of equipment. Love those things. Right? So yeah, we got to monitor at 3 airports. They love us. Okay, so now we get to start talking about appendices. Everybody's favorite topic. Appendix E, additional network requirements. Okay, how high can I put my probe? Right? Usually supposed to be in the breathing zone. Well, you get 7 meters in some you don't. A whole bunch of requirements. So that's why the guy from the office is calling. Could you measure from the ground up to the probe, please? Could you lower it 2 inches? That's what they're trying to do. It isn't that they're trying to really be that much of a jerk. They're just trying to meet the monitoring requirements. Also, drip lines, things like that. Reason they talk about that is they're trying to limit the amount of potential reactions that are going on in the probe material or around the probe, right? So there's requirements on how far you have to be from the tree, how you have to have the probe material constructed, things like that, all contained within the regulation. Wasn't kidding. I can't remember the speaker who said that if you can't sleep at night, pull out the regs. They are tremendous for that. You get through the preamble and boom, you're down. So get to Appendix E, you really have a problem. You might want to see your doctor. One of the other things we talk about when we talk about Appendix E is airflow considerations. That's when they pull up words that you've never heard of, parapet walls, things like that. How far away from this obstruction do you have to be? How much airflow does there have to be? It's all prescribed within the regulation. And so in your annual network monitoring plans, you're calling out all this stuff. And it's very specific. So they're asking very specific information, and they're asking everybody to put this in their monitoring plans. And as we all know, Region 9 is very thorough on how they want that information presented and given to them so that it's easy for all of us to figure out how well we're meeting these requirements. Then there's data quality issues. So you've got to have co-location. And as we heard earlier, that's on a PQAO basis. So those of you in the CARB PQAO, you're probably golden because there's a whole crap load of you out there with a whole lot of instruments, probably a lot of co-location. For those of us in the Bay Area or South Coast, we got to do our own. So we got a lot of co-location going on. And then, of course, you've got to document all of the above. How's everybody doing? Okay, only a couple people asleep. That's pretty good. Okay. Some other network design considerations. Again, I'm just pounding these things in. I know I'm getting repetitive, but that's what they say in all the manuals about how to give a talk. Keep talking about it throughout the thing. Make your PowerPoint really boring. Put a lot of words in there, no pictures. So thank you. So you're trying to capture the highest pollutant concentration for some pollutants. Those are NAAQS equivalents, right? Trying to get representative exposures. That's for health studies. Trying to get transport and meteorology, right? So that you can get source and area impacts so you can help your modeling guys. And then one of the other things that we tend to forget about is evaluation of progress. That's why, you're stuck in that monitoring site that's been there since the 50s and that, tile floor hasn't been changed and, it stinks. That's why, so that you can measure progress over time. Other considerations, and Jason talked about a lot of these, is special studies, things that we're now doing as air districts in California a lot more often than we used to. Somebody complains, your board member's friend calls up and says, something smells, and you got to go out and design a whole system of air monitors to try and figure out what the cause is. Those are some of the other considerations. We're trying to figure out all sorts of other things. Some of the other design considerations, we've talked about it a little bit, environmental justice. One of the big things on everybody's radar right now is that measurement technology is getting pretty small. Everybody's got one now. It's not going to be too long before everybody's going to be walking around with an ozone monitor on their phone, and guess who they're going to be calling? That's right, you guys. They're going to be saying, hey, I'm standing outside your station right now, and my ozone monitor says it's 106, and yours says it's 80. I don't believe you. I'm going to go look at your monitoring plan. I'm going to start commenting on that. So, that's one of the things that we've got a plan for. That's why we're all talking about this documentation, so that when people look at our air monitoring networks and how they're located, they can be confident that, yes, what we're telling them these things are reading are true, because they're going to have their own little measurement devices to take a look at that. One of the other things that's starting to become big too, we're all talking about infill development and trying to maximize sustainability. Well, to do that, you've got to be able to take air quality into consideration. So you're looking at future development, right? So you're trying to figure out, okay, what is the air quality in this particular area? If I develop that, are there going to be unintended consequences? Are we going to be putting people at risk because, they're next to a railroad, or they're next to an airport, or, a refinery? It's pretty simplistic, but you get what I'm saying. One of the other things, roadways. So how much traffic is there? Kind of beat that horse. One of the other things, too, is health research. I don't know how often you guys have to have conversations with health researchers, but they're always talking about more, better, more time-resolved information so that they can get a better handle on what the impacts of air quality are. And so we're being pushed in that direction. Get them more information, more PM2.5 speciation, done more often, at more time-resolved rates, so that when hospital admissions spike, they can kind of relate that to something that happened nearby. So health research is really driving a lot of this stuff too. And then, of course, one of the things that was briefly mentioned by Jason was the 5-year monitoring network assessment, where we take a look at all of this monitoring that we're doing and we say, okay, how can we be most efficient? Which stations should we close? Which stations should we keep open? Which ones are providing value? Which ones are not? If we shut this down, what is going to be the consequence? And then you have to go through that whole exercise again. If I shut this one down in this CBSA, do I meet my minimum monitoring requirements? And if you have district borders, for example, for the Bay Area, we meet some of our minimum monitoring requirements by piggybacking on neighboring districts. So, they'll have a PM2.5 monitor, and they'll be in our same CBSA. So if they shut their monitor down, now all of a sudden, neither of us is meeting our monitoring requirements. So we've got to take stuff like that into account. And the 5-year network assessment helps us do that. See, I got something in there. It moved. Did you see the money? Yeah, okay. See? Not bad. An engineer can kind of speed up the thing. Now we're kind of getting into the stuff that when I was doing air monitoring work, real work as opposed to making PowerPoint presentations. I used to be in, this got my blood flowing, was what type of instrumentation do I choose for the particular application? So now we're starting to get, okay, what kind of FEM, what kind of FRM, what makes the most sense? For example, PM2.5, okay, you think, okay, co-location, that's pretty easy. So now I want to, I've got my filter-based network. Now I'm going to put a BAM in there. Well, if you put a BAM in there, now you've got to co-locate that BAM with an FRM. And then you put another BAM in there, and it's a different type of BAM. Now you've got to co-locate that. And there's a whole bunch of other things that fall into place based on the instrumentation type you have. And then kind of tying back into what Jason talked about earlier is leveraging other networks. So, okay, I've got my NAT site, at my NCore site with my CSN site, and I want to put another speciation site out someplace so that I can compare to that compares to the nation. So now I'm leveraging everything along a certain line. And that's becoming a thing. So I can put my speciation site over here, and it compares to the rest of the nation if I do it right. Space limitations. We talked about you guys being stuck in those stations that were built in the 40s, and we just keep piling new instrumentation in there. So now your desk is this big, and you don't have any room. So you got to make sure that the stuff that you're using fits. One of the other things that we don't think about sometimes is the instrument that we're using in wide use. Can I call somebody else and go, man, this thing's giving me some weird readings. Have you used this? If no one else in the entire state has any operational experience with it, who are you going to call? So, you want to make sure that you're making your choices, not only on the requirements, but also on some sort of logic. Okay, last slide. No applause. Good, then it wasn't too brutal on you guys. I'm glad. Some additional things that you might consider. Co-pollutant information. One of the things I always get a hard time at when I'm at a national conference is the Bay Area has just a ton of CO measurements, right? Every station has a CO box, and everybody says, Stevenson, what are you doing with all that CO? Well, I use it as a QC. CO's stable. I can check what's going on. Is it a calibrator problem or is it an instrument problem? CO can kind of tell me that. So, that's a consideration. If I've got a station and, I got an old CO box, throw it in there. It's going to make problem solving that much easier. Another thing that we tend to do is, and these are just examples, we'll tend to co-locate a PM10 with a PM25, get the ratio. That tends to be somewhat stable from area to area. So now I can leverage my PM10 network and get PM25 information, right? So, a lot of different things that you can do to kind of save money and make your boss love you. Finally, data quality indicators. One of the things that's becoming a big thing now is instruments just pump out crap loads of information, right? And so if you're able to kind of access a lot of that information, you can call that up. If you've got the 4-hour drive to take a look at H2S, and you can call up the metadata and say, oh, my converter looks good, everything looks good, you'll be okay. But if you can look at it and say, oh, I should bring this particular part out because this piece of metadata is telling me that it's about to crap out, that's going to help you. So other considerations when you purchase equipment, how much information can I get on the side? Okay. Do you think I beat the documentation thing to death? Do I need to talk about that some more? So we need to document, because the next two presenters are going to talk about annual network plan. So if you think I talked about document, these guys are going to, that's the next word you don't want in the drinking game of training. PQAO, documentation. One of the other things that I wanted to touch on just briefly is something that we're trying to do, that EPA is trying to do to make your lives a little bit easier. It's the California Air Monitoring Network Assessment Tool. It wouldn't be something we could use if we didn't have a cool acronym for it. So it's CAMNet. And basically what this will do is you'll be able to put all sorts of information into this tool, and then your annual monitoring network plan will use this tool to spit out information in a uniform way so that you don't have to keep entering it into those tables and making that little itty bitty change that takes some poor guy at the office 4 hours because now he's got to go through and tab 500 times. So that should be coming out pretty soon. Hopefully we'll design it so that we can import information into it so that somebody doesn't have to do that for you, and that you can use that as you build your annual network plans, and then after that, your 5-year assessments. So that's it. Any questions? Excellent. Seriously, no questions? Excellent question. Yes, it is over. So I'll introduce our next speaker.
Let me ask one.
Oh. Thanks, Mike, for saving me. I appreciate it.
One question.
I'll pay you the $5 later.
Hello. Okay. On average, though, I'm kind of surprised that it takes that much effort from year in to year out to update your network plan. Are there that many changes, or is it more or less based on assessing whether there were changes at every air monitoring station?
Well, that's a good question, Mike. A lot of it is, trees grow. You did some probe maintenance earlier. Is it still as high as it was the last time? Was there a remodel next door? Did that change the vent from the water heater? So a lot of times, yeah, you just kind of are going out there and measuring stuff just to verify that there hasn't been a change. As Jason pointed out, there is a lot of development now going on around these air monitoring stations. So things are changing pretty quickly. So when they put together the monitoring plans, a lot of times they're just verifying that nothing's changed.
A lot of the change is just additional things that are needed in the plan, too.
Yeah.
EPA wants it. I mean, there's a lot of extra work there.
Yeah. So if EPA wants an additional piece of information that they didn't want the previous year, you've got to find that. In addition, okay, so you added a piece. Now you've got additional stuff on your roof or, additional measurement stuff. Yes.
Steve Ryder with ARB. South Coast touched this subject, siting, new sites, crowding. What do you do and how do you get sites without legislation that says, I can take this spot, this is the ideal spot? Mm-hmm. What do you use to get sites?
I'd have the guy that I usually ask to do that come and talk, but he's retired now because he can't take it anymore.
That's right. Exactly.
Basically, it's becoming, it used to be you could go to a fire station and say, hey, I want to monitor here. And they'd be like, yeah, come on, it doesn't cost nothing. Shoot, put it in there, I don't care. Now you can't do that anymore. Now you got to rent a building and rent it at market rate. So basically what we're seeing is that our board of directors will get complaints from a particular impacted community. They'll tell us we have to go monitor there, and we'll spend weeks canvassing the area to try and identify sites that can be effectively utilized. It's not easy. And usually here's the number one site, but, that isn't going to work. So you're down to like your sixth site, And so a lot of that is going to fall on you guys. You're going to get that call someday, and you're going to go, yeah, I can locate that site, and you'll pick up this PowerPoint presentation, and you'll start laughing because you'll remember me sitting up here saying, yeah, you got to weigh all these things, and it'll drive you crazy. It is not easy anymore. It's really difficult.
So you guys haven't considered any kind of legislation that says you have some kind of
we're just the Bay Area.
We find,
maybe ARB or EPA could do that.
Yeah. We find with special projects, a lot of people are enthused about a site,
yeah.
But a regular site, and we're especially having a problem with pesticides.
Yeah.
I mean, nobody wants to deal with the ARB anymore.
Yeah. Well, and I think a lot of it, too, is going to be solved with this, smaller sensor technology, to be honest with you. People will go out there with a cell phone and go, oh, geez, there's tetraethyl death here, and I want it to be monitored, and so there'll be an outcry. That's kind of the way it's working now, is the only way we can locate things is if there's an outcry and we go to the city that the problem's in, and they'll go, yeah, you can stay in this park. It'll cost you, $1,000 a month, and, when you leave, we want a new jungle gym. That's kind of the way it works now. Anything else? Excellent.